Hey guys, hope you're doing well here today. Gonna do another and maybe my final, I don't know, video helping you to get ready for the final here on different things that I saw you might need help with and that I got questions on. So make sure you guys make a good formula sheet that you can use on your test. I listed the things that you should have on it on Classroom, so check that out and let me know if you got any questions as you're preparing for that, which will be Thursday. You can pretty much have all the day Thursday. I might even be motivated and post it Wednesday night for you guys. Anyhow, here is one of the problems I'm going to go over. You need to know basic terminology with sine function. All right, first let's talk about the amplitude. The amplitude is basically the height of the wave. So if here's your function, and remember sine functions, they start at 0, okay, 0, 0. Then the basic sine function rises up to 1. All right, so the amplitude here would be 1, okay? Now, if there's another number in front of it, instead of it just being, sine of x, okay, so right here this represents sine of x. All right, it would rise up to 1 before it starts to come down. And it would rise up to 1 at pi over 2 before it starts to come down. Okay, because remember pi over 2 is 90 degrees, and the highest, the ratio between the opposite side and the hypotenuse can be is 1. In fact, that would be like not even a triangle. Because remember, trigonometry is all about triangle measures, okay, and the ratios between sides of a triangle. So anyhow, amplitude is just the height of the wave there. All right, let's look in the inside here. Now, h is the horizontal shift. Okay, now remember, you have to factor out, if there was like a number that multiplied x, you would have to factor that out. Okay, now you can't take it outside of the sign, okay, but you have to factor it out of whatever is added to it. Okay, so like for instance, if you had like y equals sine of 2x plus 1, okay, the horizontal shift would not be left 1. Okay, now remember minus goes right and plus goes left. All right, the horizontal shift on this, you'd have to factor out the 2 first. Okay, so you take out the 2, and then you'd have x plus a half, because 1 divided by 2 is a half. So this would actually only shift left a half, all right, if you had a function like this. B is the angular frequency, okay, and what that tells you, that's the angular frequency every 2 pi, okay, so it's a little bit confusing there, because if you remember, there's something else that's not here called the period. The period is how far the graph goes before it repeats on the x-axis, and the basic period is 2 pi for a sine function, but when there is a b inside of it, the period is 2 pi divided by the absolute value of b. So in this particular one, if we're doing sine of 2 times the quantity x plus a half, it would be 2 pi over 2. So the period is actually equal to just pi. So it would go pi for whenever it repeats itself. Now the period and the angular frequency are related in the fact that they are reciprocals of one another. Okay, so if the period is pi, the angular frequency is the reciprocal of that, which is 1 over pi, okay, which means it repeats itself once every pi. Okay, now you might be thinking it's saying b is equal to the angular frequency. Well, that's not exactly, I mean, that's not the full picture. It is a frequency, which means like how often something is occurring every something else. Okay, so it's the whole graph is occurring once every pi, or you could think of it as occurring twice every 2 pi, and there you have it. There's that b. Okay, so b is in relationship to 2 pi when it's talking about angular frequency. All right, so it's a little confusing there. I don't like how that's quite labeled here, but that's okay. All right, plus k is just the vertical shift, which you guys I'm sure are all fine with. Okay, now let's look at one of the ones on the homework, kind of like this. So clear all the sync out of here. Now, so you have y equals 4 sine of x over 3. Okay, so I already went ahead and graph it. The amplitude's 4. You can see that in the fact that the graph goes up to 4 if there's no vertical shift. Okay, so if there is no vertical shift, the amplitude basically tells you how high the graph will go. And then you take the opposite of it, and that's actually how low the graph will go. The period is equal to 6 pi here. Now, how did I get that? Well, remember, in every sine function, the period is equal to 2 pi over the absolute value of b. Well, b here is equal to actually a third x, because it's x over 3, okay, which is the same thing as a third x. So it's 2 pi over a third, which if you multiply by the reciprocal, you flip over a third, you're really multiplying by 3. So that's how you get 6 pi for the period. So if you notice on the graph here, it repeats itself right here. The graph starts to repeat between 0 and 6 pi. It starts to repeat again. All right, the frequency, like I said, is just the reciprocal of the period. So just flip it over, put a 1 on top of it. All right, and just to remind you guys, the sine function starts at 0, okay? And typically it repeats every 2 pi, but because it's x over 3 here, it's now repeating at 6 pi. All right, and 6 pi is, I'm not sure how many degrees it is, but remember 2 pi is equivalent to, okay, 2 pi is equal to how many degrees? All right, well, 2 pi is a whole circle, 360 degrees. That's why, you know, these functions, we use the unit circle because it's representing one trip around, okay, all the possibilities of the trig ratios, okay? So 2 pi is equal to 360 degrees. All right, so let's go ahead and take another look at some trig problems. All right, here we go. This one's a little bit of a tricky one. So we have cosine of 11 pi over 6. So let's start by graphing this out and seeing what we're talking about here. So 11 pi over 6, that's radians. And if you don't remember the conversion, okay, you maybe should write that down on your formula sheet. But remember, in pi, every pi is equal to 180 degrees. All right, so you can convert this by taking 11 pi over 6 and multiplying by 180 over pi. And that gives you the degrees that this is. Now, I'm not even going to bother doing that because I know that 2 pi, okay, is equal to 12 pi over 6. This is just pi over 6 less than 2 pi. All right, so on my graph here, I have, this is pi over 6. Okay? So we're looking at the angle that goes like this. This is 11 pi over 6. Okay, sorry, it's a little sloppy there. 11 pi over 6. Be a lot easier if I could actually write with a pen here. Sorry about this, guys. But, okay, so this is pi over 6. So we have this triangle in here. It kind of looks like this. Pi over 6 is equivalent to a 30-degree angle. Remember, take 180 divided by 6, that's 30. Okay, pi over 3 is a 60-degree angle. Now, opposite of the 30, so you have to remember your 30, 60, 90 degree triangles. Opposite of 30 is equal to 1. This side here is going to be square root of 3, and the hypotenuse is a 2 in a 30, 60, 90 degree triangle. So if we do cosine of 11 pi over 6, okay, we're putting in an angle and we're getting out a ratio. Cosine of 11 pi over 6 is actually equal to the ratio of, remember, cosine is equal to x value over the radius, okay? So x value is square root of 3 over radius of 2. Okay, so here cosine of 11 pi over 6 is equal to square root of 3 over 2. So now what we have to do is just arcsine. Now arcsine, remember, is sine inverse. So we're doing sine inverse of square root of 3 over 2. Okay, sine inverse returns the angle of a function. So we have to figure out where is square root of 3 over 2 at, okay, in terms of a unit circle. Well, sine sine inverse is actually defined only in two places. All right, so sine inverse is defined on the fourth quadrant and the first quadrant. All right, so if it was sine, okay, this numerator, okay, it's the y value, and the denominator is the radius. Okay, so since we're doing sine inverse, we have a y value of square root of 3 and a radius of 2. All right, and so we're looking for an angle. We're going to call this angle theta. So this is how you would determine angle theta. You think, oh, what angle here has the opposite side of square root of 3? Okay, well, isn't that a 30, 60, 90 triangle? See, if the opposite side was a 1, it was a 30 degrees. If the opposite side is square root of 3, then that has to be a 60-degree triangle. So this is equal to a 60-degree angle. And now we just convert it to radians. And you see there's the conversion to radians, pi over 3. All right, that's lovely, isn't it? Let's go and try to do one more problem on trigonometry here. Boop. All right, so here, some of you guys just didn't do this because I don't know if you were lazy or didn't know how to do the problem, but it says a guy wire. I think that's supposed to be a guide wire, but anyway, there's the wire. It's attached to a radio station tower. So here's the tower. Boop, boop, boop. Okay, there's the tower. It has a 30 meters on the base. Okay, it has a 51-degree angle. All right, and we're looking for the height of the tower. So we have to think which trig function would make sense here. All right, so since we're not dealing with the hypotenuse, tangent makes sense here. So we do tangent of the angle. Okay, so always put an angle inside tangent. You put the ratio inside tangent inverse is equal to h over 30. All right, so there you go. That's basically the setup. You need to multiply both sides by 30. So you do 30 tangent of 51. Put that in your calculator. Make sure you're in degree mode. All right, remember you have to make sure you're in the right mode. And then you get the correct answer of 37 meters.